Good morning, free thinkers. In today's video, we're going to talk about pulsed energy amplification and the Smith chart. But before we get there, I'd like you guys to go ahead and hit the like button, subscribe, and ring the bell. And if you're a free thinker too, and you like going over energy and how to make it and how magnets can lead to flying, then join me in this path of enlightenment. Okay, so this is the Smith chart, and it's all about reflections in copper wires. But reflections happen in more things than just copper wires. For instance, they happen in ropes. So let's take a look at this video and watch what happens with a rope when you pulse one end of a rope and then play the reflection to make standing waves.
Standing waves are a result of reflection and interference. As I send a single pulse down to this fixed end, you can see that it reflects upside down on itself. If I send a rhythmic pulse, it reflects on itself. This is the fundamental mode. Sending the pulse at twice the frequency results in the second harmonic. If I triple the frequency, I get the third harmonic.
So you can see how the length of the rope and the frequency at which we pulse the rope determine how many nodes and how much power you get along the length of the rope. Okay, the same thing applies with electricity, and this is why pulse amplification works. But I don't think about it this way. When I think about this, I think about it in terms of horns and echoes, actual echoes in the real world. So let me explain what I mean. Let's say that you had a horn, something like a tuba or a trumpet, something like this, okay? And now you play a sound on the instrument. It's a waveform. It goes out, and then it hits a barrier, a wall of some kind, all right? And it reflects back, but when it reflects back, it's a lot smaller. It's a smaller waveform. Now, this sets up a moment in time where this echo comes back and you hear it at the spot where the horn can pulse the sound again. If you pulse the sound at exactly the same time, then you get the sound plus the echo that goes out again. Now, since you have the sound plus the echo, it's a little bit louder, and that makes the echo that comes back a little bit louder. If you keep doing this over and over again, you get a runaway curve of energy, and that's what pulsed energy amplification is all about. Timing the echo when it comes back so that each time you play the sound or make a spark or any kind of pulse of energy, it grows a little bit each time. And this runaway effect is energy amplification. Now, that's not the last place it applies to either, because reflections happen within copper wires. And these reflections are exactly the same as the reflections that we saw in the horn that I drew and in the rope experiment that we watched a moment ago, okay? And the way we figure out reflections and how the standing wave sets up inside of a copper wire is called the Smith chart. Now, what electrical engineers use this for is determine if we're going to send X amount of power across this amount of distance, how big of a gauge and how long can the wire be so that we have the least resistance possible. But what we're doing with pulsed energy amplification, or at least what I'm proposing we do, is that we play this reflection knowingly and we just pulse it every single time the echo comes back. And you could do this not just on a copper wire, but you could possibly pulse your plasma globes to get them to do weird things as well. So there's my idea, pulsed energy amplification. Let me know what you think in the comments, and be a free thinker.